Chapter 22 is about further trigonometry. First, let me remind you what the old trigonometry was like. If we look at this triangle here, for example, which I'm about to draw, so I construct one of these little triangles. It's supposed to be a right-angled triangle. There it is. So you may recall that if this is the right angle, this is called the hypotenuse, the longest length. This is the angle that we're talking about, for example. Then opposite the angle that I'm right there is called the opposite, and next to the angle, adjacent to the angle, is called the adjacent to the edge. Alright, so that's grade B trigonometry. You may recall that the sine of the angle that we're talking about is the opposite over the hype. Okay. You may recall that the cosine of that same angle is the adjacent length over the hypotenuse, and hopefully I'll get tan to fit here, and the tangent of the mystery angle is opposite over the adjacent. Alright, so we can use these rules to rearrange any one of these three and to find either the op or the hype or the angle or anything else that could be asked if it's a triangle associated with a more compound shape. Again, it's great, lots of applications. Now, in this chapter, we're going to play with two new rules, well, three new rules, but two of them involve trigonometry. Consider this triangle here for now. Again, this is just an introductory video. This is deliberately not drawn as a right angled triangle because it's not meant to be a right angled triangle. Okay, so traditionally we label one of these sides capital A to represent the angle, and his opposite side in length is little a. If this side is, say, if this angle is angle B, then opposite angle B right here will be his corresponding opposite side length B. And finally, big capital C is the last angle here, and opposite C is little baby c. So we have a triangle ABC with three angles ABC, and with corresponding opposite sides little a, little b, little c. Now this is fantastic stuff. Here is a fantastic rule called the sine rule. So here we look. A divided by the sine of angle A, okay, so it's little length A divided by the sine of big A, the angle itself, is equivalent to little b divided by the sine of his angle, in other words that one with that one, and no prizes for guessing, little c divided by the sine of big angle C, so that will be that one and that one. Okay, so you can see a situation whereby if you know three of these things, so let's say for example I know angle A and angle B and the length of B, I can set up a little ratio like this to work out the side of length A, can't I? That's easy. I mean, this rule will always be given to you in the exam paper. When you open up the front cover, it will be given to you, so you don't have to learn it, but you may have to use it in this form. So sine of the angle divided by his little opposite side is directly equal to the sine of the angle B divided by his little side, which is the same as angle C divided by his little side. And once again, if you know any three of these things, you can work out the missing part. So let's say I know side A, side B and angle B, I can work out angle A, can't I? Alright, so I can work that out quite easily. So if I got the sine of A just calculated for myself, I can go shift sine and then get the angle A itself. It's really, really easy. Okay, so this will become clearer when I do a few more problems straight from the book. And the final rule is called the cosine rule. And so let's see if I can make that fit here then. Well, it's the same sort of thing, but watch this one. This is the cosine rule. A squared, in other words this length squared, equals the other two small sides, or the other two sides squared. In fact, they can even be both longer than A. It's not stuck to Pythagoras in a religious sort of way. So A squared equals B squared plus C squared minus two lots of B times C multiplied by the cosine of angle A. So just look at the pattern of that. A squared cosine angle A at the end. Okay, so A squared equals the other two sides squared, take away two lots of the other two sides, multiplied by the cosine of the angle. So what we need to know here, for example, is if we know, say for example, side B and side C and angle A, okay, so we need to know this, this and this, we can work out the opposite length, little a, which corresponds to the angle big A. Alright, so this is a way of working out a side, knowing the two other sides and the angle between them. And that's the cosine rule. And of course, if you want to work out angle B, then it's going to be b squared equals a squared plus c squared minus 2 lots of a times c multiplied by the cosine of angle capital B. Alright, so here we know big B, we know A, we know C, and we can calculate B itself. Alright, and of course there is the last one, which I may as well just record for you. C squared equals a squared plus b squared, in other words the other two sides squared, minus 2 lots of AB, look, A and B, multiplied by the cosine of angle big C. And here we have it again, little c and angle big C. Alright, now these can of course be rearranged, and I'll rearrange one just here, just this one alone. I'll do it right here in black so it stands out. Supposing I know side A, side B and side C, I can work out the opposite angle A by rearranging this equation. So first thing I need to do is, if I take away this minus 2bc cos A term to the other side, it becomes positive. So I've got 2bc multiplied by the cosine of A equals b squared plus c squared, and then subtract the minus a squared to the other side. Alright, so that's quite easy, isn't it? And then just to get the cosine of the angle we're looking for, we simply do b squared plus c squared minus a squared, and then just divide by the 2bc. Okay, take it over as one little term, 2 times b times c, and that also is the cosine rule but rearranged for working out the actual angle. And of course, once you've got the cosine of the angle using the lengths that you know, you just go shift cos and you've got the angle. And essentially that's it. Okay, so that's grade B trigonometry, and this is grade A stroke A star trigonometry, depending on how complex the storyline is. But that's it. Hopefully you can see that right there. Let's just write it up here in case my face is in the way. So I'll do it again. So the rearranged cosine rule, the cosine of one of the angles is going to be these two sides added together minus the corresponding side to that big angle, then divided by 2 lots of BC. And that's it. Now this version will not be given to you in the exam, but these 3 versions will be given to you in the exam, or one of them anyway at least. So no problems there. This will be given to you. One of these will be given to you, probably the first one there. And it makes no difference what the letters A, B and C are, as long as you're plugging the right numbers in the right place, then you get the answer that you require. And that's it. That's the introductory video to higher trigonometry, and this will all make good sense once I start doing some problems in the subsequent videos. So join me then.